I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for what is an introductory overview of nucleophiles and electrophiles for the 12th grade chemistry student. Now, nucleophiles, electrophiles are important because these are the driving forces behind many of the chemical reactions, not necessarily in organic chemistry only, but it could be in any of the chemical reactions that you would come across. Here, as we are doing just a simple overview, let's examine. The nucleophiles, electrophiles are species that have the ability to attack or be attacked by something else. And that is normally due to charge distribution variations between a molecule, or it could be the inherent characteristics of the atoms that are found within that molecule. You can have charged species which can be nucleophiles, electrophiles, but you can also have neutral species that can behave as nucleophiles and electrophiles. As an example of a neutral species, look right here. We have BF3, boron trifluoride, and look at another molecule, ammonia, NH3. Now, what's the difference between these two? If you were to do everything here by means of Lewis structures, boron trifluoride would look something like this. And you know, based on the group location of boron, this is exactly right. It actually has 6 electrons in its outer octet and it's deficient by means of 2. It has a deficiency of 2. But when you look at this ammonia, you know, you've seen this. It's going to be having a complete octet around each of these atoms, and you have that. What is the inherent difference between these two? Well, they are certainly neutral, but the inherent difference is that this will be an electrophile, this will be a nucleophile. Why? Because of the presence of these 2 electrons here in ammonia, it gives it the ability to do some sort of attacking. The deficiency of this in terms of an incomplete octet gives it the ability to react or be a recipient of an attack. When both of these compounds react, this behaving as a nucleophile, this behaving as an electrophile, nucleophile would be a species that would be rich in terms of electrons, and electrophile would be a species that is deficient in terms of electrons or even charge. You would have NH3 react in what would be a Lewis acid, Lewis base reaction. This would be your Lewis base, that would be your Lewis acid, and here you would see this complex develop, and now each of these atoms has a complete octet. But this behaved as an electrophile, it was a recipient. This behaved as a nucleophile, it was the attacking species, but there's no charge over here. The inherent ability of these to behave the way they are is simply because of the chemistry behind the octet, the incomplete or the complete octet that you see. That's all what it is. But these are examples here related to neutral electrophiles and neutral nucleophiles. Let me show you additional examples. Let's look at this example right here. We have a hydroxyl. By means of this negative charge it's carrying and a full octet it can now find a species that is deficient in terms of its octet, and we have a hydrogen ion, a cation. This can react with that and you know you're going to get water. But here you know clearly this was your nucleophile, this was your electrophile, but they're charged species. How about this? You have chloride anion, you have a hydrogen ion. These can react to give a hydrochloric acid. You know that, hydrogen chloride, hydrochloric acid, however you want to name it. But this here is your nucleophile, this here is your electrophile. The electrophile is going to be attacked and it's going to be achieving its complete octet in terms of its representation by means of a nucleophile joining it. What would be Lewis dot representation of this? You know what it's going to be. It's going to be this right here. You know chlorine is normally 7 in terms of the outer number of electrons, but this negative charge represents an excess, and that's you're seeing right over here, and that's what's giving it the negative charge plus hydrogen. You have this, and then when you bring them together, what are you gonna have? You'll have exactly what you see right over here. And what you can even do is write it like this. You have a complete representation over here in terms of all the electrons which are involved. But these are again nucleophile, electrophile reactions, but here specifically you're seeing charged species. What I want to do is spend the remainder of this time in this video looking at additional neutral species which can behave as nucleophiles and electrophiles. Take a look at this compound. We have something which looks like this, an aldehyde. If you are looking here in terms of dipole moments, oxygen is more electronegative, carbon is more electropositive. This is electropositive, that's electronegative. You have a dipole moment in this direction. Carbon is relatively positive, oxygen is more negative in terms of the asymmetric charge distribution. Therefore, this is going to be relatively more electrophilic atom. This will be the more nucleophilic atom. Now you're seeing electrophilic and nucleophilic behavior arising in the same compound. You're seeing that. And then let's get rid of some of these symbols we have. We have something which looks like this, something which looks like this in terms of charge distribution. Now you can have something which is a nucleophile, and you know it would be something like this. It can attack this over here. The nucleophile with this electron excess can find a species which is relatively electron deficient. The carbon here still has a complete octet, but in terms of charge asymmetry, because of the dipole moment, it has a charge deficiency here. It's relatively positive, so you can have something like this attack, and then you could see a compound which could show up as this. And then you're seeing this. This carbon got attacked, moved over here, and you're seeing something like that. And then you could have a cation present in that same mixture. This can attack that, and then what you can see is something like this. Now you're seeing a whole different type of compound forming. Even though it may be an unstable species, it may react to generate something else. Within a molecule, you're having electrophilic and nucleophilic properties. Part of it is behaving as an electrophile, part of it is behaving as a nucleophile, and you see the reaction goes on. Let's look at one more example. Take a look at this compound called benzene, C6H6. Take another compound which is a vinyl compound. It's an alkene, alkene, because it has a double bond, but it can also be called a vinyl type of compound because it can react to generate vinyl compounds. Anyhow, wherever you see these double bonds, they can represent a certain electron excess or electron rich part of that compound, and these double bonds, the pi electrons over there, the pi electrons can serve as nucleophiles and hunt for electrophiles in the same reaction mixture and react with them. This region of electron excess can hunt an electrophile, react with it, and then you can end up with a representation such as this, which would then stabilize. And we don't have to be too technical over here, and you'd have this. You've attached an electrophile to a benzene by means of an electrophilic nucleophilic reaction. It would really be an electrophilic substitution reaction, but it is still a nucleophile attacking an electrophile, and you're getting that. And similarly here, this region of excess electrons, or you can call it the pi electrons, can attack this, and you can end up seeing a representation such as this, and now the electrophile has become part of your alkene, which has now become an alkane because the double bond has been lost. In this reaction, the double bond is lost, but you're seeing an electrophile was attached to a compound which was behaving as a nucleophile. But in all of these cases, you're seeing here, these are neutral species. There's no manifest or apparent positive or negative charge. The only item which had the charge was your electrophile, but the nucleophile was entirely neutral. So you can see there are a variety of reactions out there which involve nucleophiles, electrophiles, and these are all important reactions that you will soon come to know in your own studies. Thank you. Have a good day. Bye.